Hello, everyone, and welcome to another amazing episode of the V-Door Locksmith Show. I'm your host, David Gibson, and today I'm really excited about this one. It's going to be a lot of fun. We are unlocking the secrets to the success. Okay, let's try that one more time. We are unlocking the secrets to success one interview at a time, and today it's not just one interview. It's an amazing presentation by an amazing team of people. We've got the IBM Artificial Intelligence, Machine Learning, and Internet of Things. Essentially their super team to be able to come on and explain to us what all that stuff is about so that we can be better educated in the industry to be able to see if one of the projects that we have that we're working on at our organizations could possibly have AI or ML implemented into it. So really excited about today's show. We've already got plenty of people watching. So if you guys would, please let me know where you're watching from, what company you work for. If you're unemployed, let us know. Feel free to engage and comment with everybody there in the comment section. Hit the little like button, and please tag a friend. Like, the show is free, so don't be stingy and just keeping it to yourself. Share it with all the other people that are out there in our industry that could use the opportunity to be able to learn about this. So I'm going to get things pulled up over here. We've already got a lot of comments rolling through. Like I said, guys, let me know where you're watching from so that we can give you guys a shout out. John DeWart, as always, watching the show. Grima, thank you so much for being here as well. Brian Dugas, I know Brian's got a ton of questions that he's going to be firing off while we are doing this. We've got Eric watching in from France. Eric's always tuning into the show, so thank you for being here as well. Where is it? The one and only Ben Amaba from IBM, who's here watching all of his employees, making sure that they don't do anything silly. Just joking. Ben's a great guy. If you guys haven't, be sure to connect with him on LinkedIn. Follow him. He's always putting out some really amazing stuff, really high-level stuff that'll get you educated pretty quick. My good friend Randy McDonald watching here in Austin, Texas. Ozzy watching from Austin, Texas as well. Drew Wood from, where does it say? Pikes Peak. It's a great place. I need to go ride my motorcycle there. Ahmed from Melbourne. So we actually have somebody on the show today who's actually presenting from Melbourne. It is like 1 a.m. there. So wow, that's pretty exciting. So Andrew watching from Georgia, Atlanta. I will say this. We had in the invite for this, we had more VPs and executive level and CEOs signed up to be able to take part in this today. So if you are a CEO, be sure to put your name down there and let us know that you're watching. We've got somebody watching from France. Doug is watching from New Mexico. Let's see if we can give it. Adonis says hello from Houston, Texas. Chowder from Oman. Oman's a beautiful place. I've been there. One place I haven't been, Brazil. So, Doana? Sounds about right. Good morning from Brazil. Thanks for being here. St. Louis, Missouri. Ryan from South Dakota. Ryan is also a LinkedIn Live person. He's a data analytics guy, but he also hosts a LinkedIn Live show. So if you haven't, connect with Ryan. Ryan, be sure to put your comment a bunch so that everybody can see. Go follow his show. He's got an amazing show. So if you've ever wanted to be able to get into podcasting, live streaming, things like that, he has a great show there. He's always putting out kind of good content there. We've got Mr. Dubé from UAE, Tunisia, UAE again. Nope, clicked the wrong one. There we go. Sorry, they start coming in so quick. If I pick something, then Hajesh from Pakistan. This is a worldwide audience, you guys. This is awesome. Absolutely enjoy this. It really gets me pumped up. All right, like I said, we've got an amazing show lined up for you guys today. So let's see, as far as the viewer count, make sure it looks like we've got everybody kind of rolling in here. Still kind of getting people in. Please, if you guys can, share the stream. Let your audience know. We'll take some time here. You can click out of this, share it, say, hey, come and watch this. I would really appreciate that. It means a lot to me. Helps me able to build the audience and everybody else get educated at the same time. Unless you're just trying to educate yourself so you can one up all of your colleagues, coworkers, and competition. That, I mean, I can understand. But eventually they're going to find the show because this is an amazing show. So the team from IBM is waiting in the green room. I know that they're excited to be able to get on here. I've been talking long enough, so we're going to run the commercial like we normally do. Maybe put in a couple more of these. I think one of them said like Costa Rica or something. Buenos Dias from Costa Oh, wait, that one said Michigan. That was definitely not Costa Rica. Nothing wrong with Michigan, though. There it is. Everything keeps moving. There you go. Mark Tomlinson, Buenos Dias from Costa Rica. How cool is that? Bulgaria as well. Wow. Lee Howe says, excited to see this one. Lee, I'm excited to see that you're here, sir. I really do appreciate all of your support. All right, guys, here we go. Let's get this thing rolling. Let me see if I can find, there it is. I'm looking for companies to be a part of this. So if you want to be a part of season 2 of how it's done, let me know. If your company, the organization you work for, if you want to nominate something that you want to see the behind the scenes on, trust me, if there's anything I can sell this show. This is a show that I can get companies signed off on because it helps them. I mean, I'm not really making any money off of it. It's just another thing that I do. And speaking of which, I heard something the other day I need to be able to speak about as far as my show. Why do I do this? I do this because it's fun. I enjoy it. There, I said it. So we'll play the commercial. We'll be back with the team. And one other announcement. Here we go. I get so pumped up every time I watch that. I don't know if you guys noticed. I just come back with so much energy every time that's going on. And my girlfriend who sits in the desk right over there, she can see me just like dancing along to it. So she's laughing at me now. So yeah, I get all jacked up for it. All right. So I'm gonna make one quick announcement. August 5th, 5:30 p.m. Mountain Time, I'm going to be on the Crude Audacity podcast, The Business of Cheap Oil. So we're gonna have an amazing session there. If you guys want to tune in, be sure to check that out. So quick little shout out to Catherine Mills who set that up. Thank you. So be sure to check out the Crude Audacity podcast. All right, without further ado, take that off the screen and bring up Jeff Baetz. Jeff, thank you so much for being on the show, sir. I really do appreciate it.
David, thank you so much. Good morning, good afternoon, good evening. My name's Jeff Baetz. I'm the industry CTO for the industrial market for our data science elite, AI, machine learning, and deep learning teams at IBM. And it's my pleasure to speak to you for the next few minutes on some research that we've conducted around best practices and knowledge sharing concerning the topic of AI in the oil and gas industry. While we have a lot of IBMers that will be providing more content around use cases and solutions today, I wanted to provide IBM's perspective on the ever-changing oil and gas industry and some business cases providing more context on where we see this industry going in today's challenging economic climate. According to a Markets and Markets report, we're finding that the AI and machine learning market for oil and gas is predicted to be worth north of $3 billion in the next 3 years, pertaining specifically to the predicted spend and investment made by companies in this market. You know, even before the domestic U.S. pricing freefall that we saw due to COVID-19, our oil and gas clients have told us in partnership with IBM that they needed to make several changes to their business, financial, and technology operations. This embracement of new technologies to improve efficiency in operations is now the new normal. When crude was north of $100 a barrel, profits were so high that some oil and gas clients did not have to make such efficiency or innovative changes to their business. Well, I think we'd all agree that the world certainly has changed over the last 7 to 8 months. And to quote the IEA oil market report, the world has never seen so many shocks over the years, but none has hit the industry with quite the ferocity we're seeing today. So the petroleum industry, as we all know, is in a major state of disruption due to COVID-19. And this pandemic has created a situation where mistakes just can't happen that will only put more pressure on the industry already under immense financial pressure. Focus on digital transformation must be the top priority for oil and gas companies to reduce risk while improving operational efficiency in the process of making more conservative and capital decisions. Concerning the AI solution set in the oil and gas industry, we know that big data is everywhere. There's historical operational data, data in silos, IoT real-time sensor data at the well or oil field level, all that can be part of a company's digital transformation digital maturity path and beating your competition. Enabling a cognitive, mature approach allows AI, robotics, blockchain, IoT, analytics, and digital twin technology data to be incorporated into one consolidated and, more importantly, mineable repository to make better and correct business decisions. Past failures data, past successes data, gathering data from different sources and domains, they're all part of this nirvana-based cognitive solution that learns over time and never stops learning. It learns and enables petroleum companies to make one-and-done, confident capital decisions. Author Klaus Schwab wrote The Fourth Industrial Revolution and defined this revolution as the fusing of the physical and digital worlds, specifically regarding how artificial intelligence and IoT solutions can help companies explore new ways to execute their ever-changing business strategies, needed improvements, productivity improvements, expansion of operational insights, and lastly, predictive maintenance enablement. W. Edwards Deming, the well-known American statistician, said, "Without data, you're just another person with an opinion." AI and IoT solutions for the oil and gas industry comprise of applying predictive asset optimization, optimizing upstream and midstream operations, and modernizing technologies for environmental and human monitoring and related logistics. Solutions exist for well drilling optimization, well predictive asset optimization, and well production optimization, all leveraging real-time AI and IoT sensor data and predictive modeling, assisting in the prevention of equipment failure and improving operational efficiencies. So with all this, David, how does one get started in stopping this unfortunate concept of pilot purgatory? Well, first, an investment must be made in the infrastructure of the discussed cognitive approach and must be business-driven with executive sponsorship. On-premise, hybrid cloud, or 100% outsourced cloud solutions exist from the top technology providers and are readily available. Second, we need to understand that AI is a journey, not a destination, and planning at every stage is critical. And third, interview, assess, and pick a solid and proven business partner. Historically, oil and gas companies have had older legacy systems that manage their business and operate in silos. An agile approach is recommended to be able to pivot and pivot faster with readiness from a business change and technology change perspective. Cognitive solutions allow companies to find the path in their data. Software exists now that picks up and learns corporate jargon, understands questions and requests, natural human language, and slang without any coding. Processes can be learned, and with cognitive software solutions, it continues to learn and never stops learning, uncovering optimization opportunities, paths within your data, and defining options and ways forward that are confident and correct for drillers. Answers can provide immediate impact as the value proposition. Additional oil and gas related use cases we are witnessing from our clients are focused on pipeline monitoring and leak detection, refinery predictive asset optimization, augmented reality support, enhanced oil tanker scheduling and navigation, enhanced truck scheduling, and office building management and related energy efficiencies. Businesses that keep pace and operationalize their data will win regardless of the market or industry vertical that they are in. So with this introduction, I would now like to introduce Gandhi Sivakumar, IBM Distinguished Information Architect, Data Scientist, and Master Inventor, to talk more about some success stories that we have within IBM's oil and gas and industrial market. Gandhi, go ahead.
Thank you, Jeff.
Very much, Jeff.
And never mind. Don't let me interrupt.
Go ahead, Dave.
No. Your show. You go ahead. I
Okay.
insist. It's 1 a.m. where you're at, so we're having fun, everybody. So, hey, guys, if you're watching this, enjoy, ask questions. Now's the time to be able to do it. Sorry. There we go.
Yeah. Thank you very much, Dave, and thank you very much, Jeff. As Jeff mentioned, my name is Gandhi. I am based out of Melbourne in Australia, and I work as an executive architect, going across clients to do transformation in the modernization of information architecture or the data science as well. So I'm kind of going to talk to you about key success stories in the journey I have been leading across the clients. One of the key success stories is about Woodside. Woodside is an oil and natural gases industry based out of Australia. They kind of play across the four different verticals like any oil and gas organization in terms of planning, developing the project, extraction, market, and trading, right? So in 2015, Woodside kind of came to us asking for help in a couple of things. They do have a very strong data scientist team, all PhDs are doing excellent jobs in terms of predictions and so on. However, they did actually kind of want to leverage the data, whatever they had accumulated in the past 30 years, data in multiple formats. In fact, I had handled data even where they did actually do the OCR extraction of engineering drawings, which was done like 30 years before. So the in so we kind of started the journey across the AI ladder, which I'm going to talk about, right? So what you see here as collect, organize, analyze, and infuse is the information architecture and the AI ladder. In IBM, we do strongly believe that without a proper AI, you don't. Without a proper information architecture, you don't have a proper AI at all. So that means you start kind of analyzing the data, collecting the data from various different sources, data in various formats, in various volumes, coming in various speeds and so on, right? All the big data aspects of it from various data sources, as I said. And once you actually kind of collect the data, you need to organize the data, catalog the data, and manage the data properly so that you can you have to view data as an asset to give the best value of the data. Then comes the analytics part where you can build the models, whatever type of models you want. It could be starting from the rules based model or all the way to machine learning and deep learning models and so on. And then you kind of take the models and infuse and put it into production to get the value to the business. So as far as Woodside was concerned, when we started the journey in 2015, it was like a team of three people, and we kind of on and off engaged our labs based out of India and also the research labs, a combination of resources across, and we spanned across this entire stack. So we kind of connected to multiple disparate data sources, unstructured data, structured data, and as I said, even we kind of extracted data from OCR, of scanned images and so on. Then we kind of organized the data. I would If you look at the evolution of the platform, realizing platform itself, it had evolved a lot, but certainly at that point in time we kind of actually leveraged the existing capabilities to sort of organize the data. And then we kind of did rich text mining capabilities, applying all the all the possible algorithms, best algorithms to fit the data footprint to get the value to the business. So if you look at, I'm just going to talk about the examples of the use cases in the following slides, but then what you see in the right side, a great picture is the picture of our IBM CEO and our IBM ex CEO Ginny, and the CEO of Woodside, Mr. Peter. So that this program successfully transformed to the biggest cognitive transformations ever done in the globe, and I feel very proud about it to have led that. Now, the key business benefits, what we could see is, 75% of the time, a reduction in the time actually spent in, and the time spent ideally in kind of searching the documents and then getting the value out of it, right? So that's one of the key improvements which we saw, and then which kind of turned out to multi-million dollar savings from the employee cost perspective. And not only that, right, accelerated expertise by kind of exposing 30 years of tribal data data. And obviously, all these were actually kind of all these were awarded, or a credential would say got credentials, like getting awarded from the Australian and international safety regulation and so on, which I'm going to talk to you in the next slides. Next slide, please. So this is the first project which we ever did. So this project is called Watson for Projects. This project was instantiated by the X Communications Office, where we had to develop a real-time chat bot, or a virtual agent, to enable people even operating in offshore rigs, like 80 kilometers from the land and so on. They could actually kind of use a lightweight browser-based capability, even using their mobile phone, and then ask questions in terms of a corpus base which had millions of documents, and documents from at least you could see 30,000 capital project documents with various hierarchies, all those ingested into it, and 30 years worth of documents. So here it kind of not only saved the expert, the SMEs time in terms of looking for the right information. It also enabled the availability, all the time availability, rather than, if in other words, if this use case was not built, then all the time the SMEs had to actually spend searching for the right answers. It's not only that, right? The new entrants who actually kind of would say underwent a lot of employee retirement as well. So new grads who had been deployed in the field and so on, they did not need to leverage upon the other SMEs. Rather, they kind of leveraged this solution, whatever we did build. And that's how it kind of became an extremely successful first program of work. And it's not only that, we kind of constantly monitored, and through multiple interactions with the end users, we kind of increased the adoption strategy as well, and that turned into a great success. So the technology we kind of used for this was based on the Watson Discovery. We do still have this, the same, this product is still having the same name, which is all packed in a Cloud Pak for Data platform, in the IA and the AI platform. So can we move on to the next slide, please? So this is another great project, right? The success of the first project, because they kind of invested on a slight trial basis, and when they saw the success, they wanted to actually kind of leverage another product, another solution. So this solution is actually kind of think of like, at the back end, always we do have traditional applications, right? How do you actually kind of give a cognitive flavor to all the back end applications? So we kind of put a cognitive wrapper in the front end for all the traditional applications which reside at the back end. That it was even a kind of a finance system. For example, the executive is sitting from his cabin, he could actually kind of ask a question: what is the sort of budget left out for this current year, and what was the kind of budget which I have used, and so on. So at the front end, you have a cognitive flavor, or the AI flavor, and at the back end, it kind of goes and interacts with a traditional application, a finance SAP application, and brings in the answers. And then at the boundary, it kind of marries the traditional application with the cognitive application and gives the answers in a cognitive flavor. So this as well was an extremely successful program, and has been, they kind of keep on increasing this to actually kind of go on integrate with multiple enterprise applications at the back end. And obviously, this as well is helping out people in the front end congees. It's not only the technical level, but also at the front end congees level. And this is another extremely successful program I would really wanted to actually mention about. If we move on to the next slide, please. This is called Watson for drilling, right? So there are well completion reports, and many of you are in the from the natural resources industry in the call, right? You understand that the well completion reports actually kind of get published. It's not only from the open source, but also it's openly available, but also the reports whatever the company had earlier created. For example, in the exploration phase, right? using the existing reports, they wanted to actually figure out whether there was a critical issue in this particular area. The critical issue could be like, if I actually kind of qualify this particular area to do the drilling of the wells, will I incur a fracture, or will there be a kick, or will there be, it's called geohazards, if many of you would know, or sometimes even human losses because of the incidents which happen and the gas comes out and then explodes and so on. So they proactively kind of wanted to figure out a solution to see if there were any other incidents in this particular locality and so on. And that was, it's not only for proactive thing, but also for each of the drilling. The cost for drilling each of this was about, each of the drill was about $50 million, and they wanted to proactively figure out if it is going to be of a value or not. And this was another successful program of work which we actually kind of implemented, sucking in 3,000 well completion reports and so on. And this is being used by the exploration team. The exploration team is a closed team of people, and it's completely driven by SME. We kind of leveraged their SME expertise when we did the modeling of the text around this, when we developed this project. So it was like an embedded team. We never differentiated between IBM and Woodside at all. Another success story. Can we move on to the next one, please? Okay, so this is called Watson for health and safety. So Woodside actually kind of wanted HR. This is the program which was initiated by the HR department of Woodside. We wanted to actually kind of figure out the incidents, get the summary of the incidents, whatever happened. It's not the kind of incidents, right? It's also kind of inferring the incidents from the natural language text, whatever was written. For example, if somebody incurred an injury below the abdomen in 2 or 3 areas, then that would be considered as a critical 2, or critical 1 is something else. And then if it's a minor injury, or whatever, right? So reading the summary of the incident along with the structured information, we wanted to qualify that incident, and then that incident will be actually packaged together and as an executive summary, and it would be distributed across the various key executives across Woodside. So this is called Watson for health and safety, and this as well kind of got through a credential of Woodside being awarded, as you saw in slide number 1. This is another use case I thought I should actually kind of talk to you about. If we move on to the next one, please. So this kind of talks about the transformation methodology, as you did hear from Jeff, right? The journey of AI is actually a journey. It's and also it has to be collectively done together between the parties. So in here, it's always like we kind of co-work with the client. We don't differentiate between them and us, and then we do have an embedded team always. So in Woodside, we kind of formed a cognitive center of excellence, where we had an embedded team of Woodside as well as IBM, and a cross-functional team members across working across multiple programs. So we have key members embedded in the COC team, but then they will be deployed across various programs of work, and will be engaging the SMEs and working to give the best to the business. So this, I just wanted to talk about like an one-liner and insist upon that it is a collective exercise altogether, and we will succeed collectively in the journey. So let's go on to the next slide, please. Yeah, so the next one. Thank you. I just also wanted to give you a highlight of another mining company which I have been working on the past 2 years. Here, this mining company actually has got global presence, predominantly in Australia, but they have global presence, and they extract copper, iron ore, zinc, and oil and gas as well. And it is ranked as the world's largest mining company, in fact. So they kind of have data science team of about 200 different data scientists spread across the globe, and the data scientists have been developing models in their own environment, and the models kind of did not get value to the business. And some data scientists, especially the millennials, are very passionate in kind of leveraging the Python based coding programming language, while other generation of data scientists, they kind of were comfortable with R coding or Scala coding and so on. And this lack of collaboration was missing, and then they wanted an integrated platform, and then they came to us about 1.5 years ago. We kind of gave and positioned an integrated data science platform. When I say data science platform, it's also the information architecture packed together. So we did those. In the earlier generation of the platform was called as DSX, Data Science Experience Manager, and then SPSS. So these two were two siloed verticals catering to two different types of data scientists. DSX catered more to the millennials, who were comfortable in Python based coding, R based coding, and so on. Whereas the SPSS one was drag and drop based. For the data scientists who are comfortable in drag and drop based capabilities, and then building the models and so on. So the key thing here is, I just wanted to insist, one, think of it like a two-tier, right? The client kind of most of the clients you do see in the industry, they kind of have invested money in the data lake. So here as well, they had invested significant amount of money in building the Hadoop based data lake. And when we brought in the data science platform on the top, certainly we had to leverage the data within the Cloudera platform. So the beauty of this platform is it can actually push the jobs from the data science platform to the Cloudera Hadoop environment itself. So that said, you are achieving two things. One is the investment which the client actually made on the Cloudera Hadoop environment, because you are eventually going to use the compute RAM capacity, as well as you are going to actually leverage or execute the models closer to the data rather than moving it across two different stack. And also the second thing is, obviously, as I said, pushing the models, or doing even data processing. For example, you don't need to actually do some data processing things by pulling the data from the Cloudera environment to the data science platform. Rather, you can push the job and get that executed and get the results alone back. So I just wanted to exclusively talk about this because it kind of converges both the investment the client has made in the Cloudera environment or Hadoop environment and the data science environment. So we kind of did a very complex project called legacy document processing, where again documents spread across like 20 plus years of data. They just wanted to, it's about 80 terabytes of data, as you could see. They wanted to actually kind of do text mining to extract the minerals and then put it in the Hive database, and then from there the end users would actually kind of use it for various types of ideally the exploration phase is what would actually leverage a lot of this, and we were able to successfully implement this. This again, we kind of used Python based libraries. We kind of plugged in the data science platform to the Cloudera platform, get the models built there, and then deployed the models here. On the other hand, there is another project which we did that is using drag and drop models, data science models, through SPSS tool. Again, there as well, we kind of pushed a lot of data processing techniques. For example, in the Impala databases were predominantly used by the data scientists who actually leveraged who were engaged in the asset management team. So we kind of did a lot of data processing closer to the ideally within the data lake environment itself, in the Impala database itself, and then integrated this to the SPSS platform. And this is actually kind of a pretty proactive maintenance of the Caterpillar trucks, and this is another successful program of work. And now we are continuing to work on much more complex projects. So these are the key things I really wanted to talk to you about, the success stories. So in short, we are here to actually kind of help you out in the journey of the information architecture and the AI one together collectively. Yeah. Thank you. Dave?
All right. Well, thank you very much for that. We do have a couple of questions. So we do have a question. Can different size firms take advantage of these solutions in AI that was seen at Woodside? Any areas you would recommend to the listeners and where to start?
Different what Dave?
Can different size firms, different size companies take advantage of these
Yes.
solutions?
Absolutely. So we always adopt a strategy, right? We start in a small manner and then we kind of scale and so on. So certainly, yes, the frameworks what we build is normally in a very small level to give immediate value to the business, and then we kind of scale. So that is something which the same strategy or model is something which would be applicable for even a medium scale organization or a smaller scale organization. Yeah, happy to help out.
Excellent. Well, I know that we've got more coming up. We'll bring Jeff back on. Jeff, who do we have next, sir? Jeff, you're on mute. I will take you off mute. Wait. Oh, we both clicked at the same time. Nope, not working. Can't unmute your guest because they chose to mute themselves.
Sorry, I'm back on. I'm back on. Kahila, are you ready?
Thank you, Gandhi, for your presentation.
I was actually waiting for Gandhi the question to be ended. Yeah. Thank you, Gandhi, so much.
All right, we're all getting off the screen and let you take care of it. Thanks, Kahila.
Okay. Thank you, Gandhi. Thank you, Dave, so much. My name is Kahila Mokhtari. I received my master and Ph.D. in petroleum engineering. And before joining IBM as a data scientist, I worked in Halliburton as a data scientist as well, and then with IBM now in Cloud Pak acceleration team. So today I'm gonna talk about one of the use cases that we did in oil and gas industry using AI. This is predicting the drilling rate of penetration, ROP, by using a neural network models. So the major portion of the well capital investments actually is spent on drilling operations. Decreasing the drilling operations actually is mandatory in oil and gas field because to reduce the well cost. So the ultimate goal is here to increase the rate of penetration, ROP, which is a drilling speed, with less cost while maintaining safety. So reliable and robust prediction of rate of penetration, ROP, is highly desirable. So in this use case, the main challenges with ROP prediction arise from the fact that ROP get affected by many interconnected factors, which would make it so difficult to infer the mutual effect of each individual parameter. There is no exact relationship between the ROP and affecting factors. There are actually complex and really nonlinear relationship between them. Therefore, our aim was to use the artificial neural network to build a feed-forward neural network to predict the ROP and capture the effect of the changes in drilling parameters. Next slide, please. So let's start with the data. So how we did that? We gathered the data from the 3 vertical wells that they were drilled onshore in carbonate formation and using the same conventional bottom hole assembly. A total of 15 drilling parameters were gathered, and these parameters gathered from rig and build parameters, from the formation and drilling fluid parameters. And out of these 15 parameters, just 8 parameters were our interest to use in this case study. And it revealed that the data set varies widely as a result of the different lithological units penetrated. As such, the data normalization was carried out as a part of our pre-processing. This brought the various data within the same range to align their distribution and prevented a biasing of the model toward large values that are presented in the data set. So next slide, please. The ROP prediction, the rate of penetration prediction, was built using an artificial neural network with 8 input parameters, as you see from the figure on the right-hand side. These parameters are weight on beat, the beat rotation per minute, the rotary torque, the beat size, stand pipe pressure, flow rate in gallons per minute, mud weight, and mud viscosity. The optimum number of neurons and layers was selected based on achieving the minimum absolute percentage error and the maximum correlation coefficient as the two governing factors through several trials. The result of this work showed the potential of the fast and flexible neural network approaches to model the ROP with high accuracy while maintaining running speed. Therefore, the drilling engineers can make their decision according to accuracy and computational demand in practical use. Thank you. I'm ready for your questions.
Wow, that was quick, but I am definitely looking forward to some of the questions. So I do have a question. Was this used going forward in future wells, or was this just used in being able to retroactively look back at some of the wells that were already drilled?
No, there are so many wells that already drilled.
So do you know, are you able to mention whether the client is able to continue using this program?
Yes, they are. They're using the predictive model for the future forecasting.
Okay, so definitely, as soon as you talk about ROP, everybody's going to start firing off questions. So you could create several neural networks by making one for each bit size. Is that possible?
You could create several neural networks by making one for, yeah, we can do that but since we are varying also bit size, there is no need, but yeah, we can do a neural network just for one bit size, but varying with other input parameters.
What about the bit hydraulics? Surely this has big effects on the ROP as well. I'm not sure who said that one. That was Scott McNeil. Sorry. Like I said, guys, sometimes you get to be just a blank anonymous LinkedIn user when it comes over to the StreamYard program. So
yeah, definitely it has a bit hydraulic effect on the ROP as well. But for this specific case study in terms of hydraulic of the bits, we just use weight on bit and rotary speed on bit.
So we have a question from over on YouTube. Emmanuel says, what's the relationship or difference between digital twin and AI, and how does this fit into this particular case study?
Maybe I cannot answer this question because we have not taken into account the digital twin here, but yeah, like I cannot compare it with digital twin for now. Sorry.
Oh, no worries, no worries. John DeWar says, what scale has I'm guessing, has this been applied, and what were the results?
The scale, is it asking if you're asking scaling the parameter? The scales is between 0, 0, 1 scaling and the results.
I think more of like, has this been put on mini rigs? Has this been put worldwide?
Oh, okay. Yeah, this is just applied on one rig, which is the 3 wells drilled which have the same assembly in the same carbonate formation. So pretty much the 3 wells that we use are similar in terms of being similar parameters, and the results was around, we got if asking the result of the model, the accuracy was around 0.9 for the correlation coefficient.
So this was just doing to be able to predict what the ROP would be.
Exactly, to predict the ROP.
And giving the drilling engineers the opportunity to be able to change parameters to see what would increase the ROP.
To see the changes in their the effect of the changes that they can make, somehow do the optimization and capture the effect of the changes in their drilling parameters.
All right, we do have this one. So how about lithology? Have you applied the algorithm to only one field?
Actually, we used in terms of the lithology, we do not have direct lithology as an input here for our data, but we applied the algorithm for just one field, which is just 3 wells in one field that they drilled and give us and it was onshore on carbonate formation. Yep.
So that answers Brian's question, is how many wells? It was 3. And
3 vertical, yeah.
Oh.
3 vertical wells, yes.
Have you taken into consideration a drilling dysfunction that will potentially affect the ROP? So things like stick slip, bit whirl, bit bounce?
Not for this use case. No, we didn't take it into account.
Okay. All right, guys. Well, we're going to keep moving on here. We have we can come back and visit all of these guys. Please keep asking questions. We'll keep this being as involved as we can. Obviously, everybody's getting fired up about this topic, so please feel free to tag somebody in the comment section who you think may be able to learn something from this, or who you think could potentially, maybe within your organization, start to be able to gather up some data and start to do some AI and machine learning things out there in the field. So let's see here. Shot, thank you. Oh, got to take that one off the screen. Thank you so much for being on here. And there we go. And take myself off.
Okay. Hi everyone. Thanks David. Thanks Kahila. I am Lakshmi Mishra and I'm a data scientist with the data science and elite team within IBM. And today I would like to discuss a use case that we did recently for a client. But before I start the use a little, as mentioned earlier by Jeff. Sorry.
Can we stop? I think your microphone might have been covered up there. There we go. Yes, we can hear you so much better now. All right.
I'll just hold it then.
No worries. Right. We want to be able to hear all of the beautiful and amazing things you have to say. So I will go back off. Replay.
Yeah, thanks, David, for that. So yeah, I would actually want to discuss a use case that we did for a client recently. But before that, I would give a little bit of background about what this use case was and why it's important. As mentioned by Jeff earlier, machine learning and artificial intelligence can help optimize and improve multiple core processes in the oil and gas industry. And it can be used for all, like upstream, midstream, downstream operations. For instance, machine learning can improve upstream operations like hydraulic fracking, the subsurface exploration, well production forecasting, and aid in operations like searching for potential underground or underwater crude oil and gas with soil layer sequence matching, hydrocarbon prediction based on historical soil and hydrocarbon structure, and drilling optimization like the one that Kahila just discussed. We can also use do machine maintenance and supply optimization of delivery products more effectively with machine learning, as well as improve emission monitoring and blanketing, drying processes, etc. But coming back to the upstream and downstream operations, a lot of the parameters that we use, the simulations and computations in the industry are based on external influences, like localized stresses of the soil, the wellbore, the soil layers around the wellbore, tortuosity of the reservoir, the existence of traps that lead to making field decisions, all of which can actually be improved with machine learning. Next slide, please. So one such process that we tried to solve with machine learning was optimization of fracturing treatment for unconventional reservoirs in order to maximize the dimensionless productivity index of the reservoir and reduce the risk of making the bedrock unstable. Hydraulic fracturing or fracking is a process that is intended to create new fractures in the bedrock to improve the production rate of the drilled well. But it's also important to ensure that the bedrock is not cracked extremely and doesn't make the surrounding rock layers unstable. To achieve this, optimization of the treatment parameters like treatment volume, pad volume, propping, agent volume, the injection rate of the proppant are all required. And these are factors that a petroleum engineer can actually control. So we need to be able to optimize them before we act upon these parameters. However, these parameters depend on dimensions of the prop fracture length and width and height and all the physical properties of the fracture, like conductivity of the prop fracture, that are possible within the layer of the soil as well as close to what you would expect. And these dimensions can be predicted from localized stress profile using machine learning and artificial intelligence, as there are no direct mathematical relationship between the two sets of parameters. Traditionally, you have neural network simulators that are used for this problem currently, but to find trends and predictive importance of different parameters that aid in the prediction of these dimensions, you can also use more powerful algorithms now, like gradient boosting trees, especially because you have a lot of historical data available. And this approach was actually explored by a research by Schlumberger some time back. And this was the exact approach that we took for our project. And we realized that XGBoost and LGBM can be used for solving this problem. So the resultant model helped us understand the correlation of various stresses with the predicted dimensions, the length, width, height, efficiency of the fracture, etc. Post the prediction, these parameters were fed to a decision optimization model to predict the treatment parameters that were based on the mathematical equations, relationships that have been explored in various researches till date. Next slide, please. Yeah. So information around this optimization model performed really close to the model that the industry standard simulators had. And the added benefit to this was information around pre-existing faults in the bedrock could also be fed to the model, and the decision optimization models especially, and it could uh, optimize the existing model based on the extra features that we feed in to the system. So we could observe their impact on the treatment parameters as well as the initial fracture dimension parameters that we had. And the resultant model output were similar to the outputs of the industry standard simulator, but with the added benefit of being able to monitor the performance of the machine learning model over time and tuning and retraining it for desired control parameters while observing the impact for those parameters on the model. So this ensures highest possible cumulative production while reducing the cost of for treatment, the danger of leakage and instability post the treatment for more with more understanding for the underlying process itself. And you can trim these models specific to an area, which was an added benefit that you could have with all these models separately. And that was it. Dave?
I'm here. I'm coming back as quick as I can. All right. Sometimes I have to find where the mouse is at because I'm paying attention. So, guys, if you guys have any questions about this one, please throw them off into the comment section. We really didn't have anything come up during this one, but giving everybody the quick little time. So we do have a time delay. I don't know if you guys know that. There's a 30-second time delay between when we talk and then when you see it on the internet. It could actually be longer in some other areas. I haven't quite tested it out that much with YouTube, but if you guys do have any questions, let me know. As of yet, I have not seen any, and we don't have any of the prior ones, but we do. I actually think, see, that was kind of back to the previous talk. I think we're going to have to bring Kahila back on to be able to talk about hers, because anytime you talk about ROP with a whole bunch of drilling people listening, that's what's going to get everybody going. All right, so Arjun, are you ready to go, sir? If you give me a thumbs up there, then we'll bring you on.
Yeah, I'm good to go.
All right.
Hey, sorry, Dave, go.
No, you go right ahead. I'm getting out of here. It's all you, sir.
Okay, great. Hey, everybody. My name is Arjun Ramsunder. I have a petroleum engineering degree from the University of Texas at Austin, and currently I work for IBM in the industrial market. Prior to working at IBM, I was a field engineer for Schlumberger, working as an MWD. So something I want to talk today with you guys about is a little less oil and gas specific and more of a general industry or more of a general data science use case for AI ML that can really just accelerate any business in general. So here it is tied to oil and gas. So a large operator was beginning a project that would take many years and billions of dollars to develop. Obviously, as you know, an integral part of developing any new project is well planning. However, this can take a year or more and millions of dollars due to not only the detailed information required, but also the time involved in collecting and interpreting data. In this particular circumstance, it was approximated taking anywhere from 12 to 18 months to collect and scan the data required to paint a picture of the geological landscape regarding formations to drill through and pay zones to target. These well plans and asset development require collaboration from a variety of different teams, including reservoir engineers, drilling engineers, geologists, and seismic interpreters. Traditionally, these lines of businesses have been very siloed and can result in lots of redundancy and miscommunication. The inefficiencies and operational bottlenecks can multiply the amount of time it takes to complete projects such as this, which do require a lot of collaboration. The large operator was able to leverage several open source technologies and AI to migrate all of their data into one easy access repository. This included a variety of different data types such as well log data, economic analysis, topographical maps, seismic data, you name it, it was all there. The initial trial was successful and allowed the team to seamlessly collaborate and take advantage of their multi-cloud environment to access this data. As a result, the efficiency increased and the time frame decreased. The time frame was able to be cut down for drill design by about 30% because of this easy access repository, as well as the processes they'd streamlined while building this up. Additionally, the team was able to save 40% of time on data preparation because of the workflows that they'd established while they were developing this project. Because this project was so successful, the platform is now being adopted across other projects and other lines of business in the company. Thanks, guys. I was just keeping it short and sweet. Dave, back to you.
You guys are surprising me with how quick these are. All right. Well, a success story. So I don't know if we have much more to talk about than that. Yeah. All right. So Kristen's up next. Kristen.
Thanks. Hi. So I'm going to talk a little bit. Well, first, okay, I'm Kristen Summers. I am the AI CTO of IBM's Data and AI Expert Labs and Learning. And my background is a little bit different from, I think, pretty much everybody else who spoke today. I have a PhD in computer science, and I've been doing AI and machine learning and things that we now call data science, since before we called those things data science, and throughout my career in various industries. So I'm going to talk today a little bit about underlying concerns that make possible the kinds of success stories and use cases that you've been hearing about. So things to take into account about your data and how to use it, and things to take into account about the specific AI task and how to build models. And like Gandhi, I'm going to structure this a little bit around the AI ladder. That's a construct that we like to use in IBM. It's helpful in sort of organizing the thinking about what goes into an AI solution. So as Gandhi noted, first you collect your data. You need to have it in order to be able to work with it, right? Then you organize it. You need to know what you have and be able to access it. Then you get into analyzing it. And that's where the core things happen that we usually think of as AI or data science, right? Here's where you're predicting values, you're optimizing things, you're estimating values, that sort of thing. I would like to take just a little detour into one of the earlier questions. Something like a digital twin would certainly fit in this general analyze category. Historically, of course, we don't quite talk about that the same way we talk about AI. Digital twin is sort of more aligned with simulation, and where you are looking at a particular situation and you've provided the information about, you know, how it should go under different circumstances, and then you're simulating what happens. AI is historically and typically about more generally estimating what's going to happen under a variety of circumstances. One of the things that means is that they're totally compatible with each other, right? You might be using AI, whether it's machine learning or whether it's a complex rule base, to provide the basis on which you're simulating in something like a digital twin. So that was a little detour there, but the analyze rung is where the core of all of those things happens. But once you've done that, you're not finished, right? We have a fourth rung, which is that you want to infuse that AI, meaning you want to bring it into your workflow. You want to be using it consistently and reliably in your business setting, right? So that's kind of how we look at these things. So when I talk about these considerations in the background that enable all the great things we just heard about, when I talk about data, I'm really talking about the collect and organize rungs of the ladder. And as then we move into the particular AI task and how to use it, that corresponds to the analyze and infuse rungs. So if we look at it that way, oops, I'm not progressing in the right way. Hang on. There we go. If we look at it that way, and we look first at collecting data, right? So you have some AI task you want to do. At a very basic level, it seems almost too simple. Well, what data will you need for the insights you want, right? You have to think about that and make sure that you have it. But there are always some subtleties to that. What information do you need that's going to have some signal in it for the thing that you're looking for? Where does that reside? What types of data is that in? So you notice, like when Gandhi talked about the amazing suite of projects at Woodside, she was very careful to talk about what's structured data and what's unstructured data, right? And there's a reason for that. If you look at, for instance, the information that was in the well completion reports, right? There was potential drilling hazards information in those reports. That meant it was in unstructured data. So they had to collect that data, right? And they had to store it in a way that represented its unstructured nature. There's a little bit of structured data that went with it that helped to interpret it. But if they had done something like tried to take out a few of the top fields and then thrown away all of that text, then they wouldn't have been able to go back and apply language processing to get the information out of all that highly variable language that Gandhi talked about. So it's important to get it and collect it and store it in a way that's appropriate for the data type. You also have to think about history, right? So they needed a long history of those reports. If we look at that same example, you want to look at how far back do you need to go? Some of that is because of the question of how far back is the information you need that you're going to pull from, right? And some of it is about training your model or developing your model. So if we take the example of the well completion reports, suppose they had just looked at the last, some very recent ones. There might not be enough variation there to develop a model that's really going to help them appropriately going forward. What if all the recent ones were written by the same person and they tend to express themselves in the same way, right? Then you might wind up with AI that's very good at understanding the potential hazards as expressed by that person, but as soon as somebody else is writing the reports, then they're not. Or suppose that all of the recent reports were from an area that, really shared one particular potential hazard. And so you might get very good at recognizing that potential hazard, but not at others, right? So you want to think about that when you're looking at how far back you need to collect. And then always, there's the question of overall data quality, right? It's just super important to know what level of completeness and reliable accuracy are you going to need in this data for the kind of analysis you're going to do, and how can you get that, right? So suppose you've collected all of that and you have all that information. What happens next? Well, then we need to organize it, right? We're going to try to figure out what all that data is telling us in some way. So this is where a story like Arjun's comes in a lot of ways, right? You want to look at how your data can be organized to support the analysis you need. And he talked about the tremendous value for things like well plans and asset development of having a consistent repository that's easily accessible by all the people who need to analyze it. That's only going to be more true when the things you're going to do with that data are AI and machine learning kinds of tasks. You're going to have to figure out what data you need. There are going to be, different tasks you want to do with it, different ways you try working with it. Having it consistent and reliable so that you're not spending your time figuring out how do I access this set, how do I access that set, turns out to be super important. But once you have it, then obviously the next big question is, what are the semantics of that data? What does it mean? What are all of these things, right? So, and that has to be at a very fine-grained level, right? When you look at individual values, you need to know what they are, what they represent in, say, your database table. So, for example, if we think of the example that Kahila described, where she was talking about predicting the drilling rate of penetration based on the data from those 3 wells, right? And she's using things like rig and bit parameters. Well, she's going to need to know exactly where does that parameter lie in the columns of data that you have? Which column is it? And if it's different for the 3 wells, you need to know that so that you're getting the right thing and bringing it into the input to your model. And it's not just what if the data is stored differently for the wells. What if it's stored consistently now, but it was changed at some point in history, right? You need to know that. Otherwise, you might reach back farther past that point and not know that there was a change, and now you're misinterpreting that data, right? So you really want to think about stability and governance, and hopefully you have some like data operations and governance procedures that help with that. All right. So suppose that you do, though, have all your data organized, you've got all of that set up and it's ready to go. At that point, you're halfway up the ladder, right? Now we've talked about the 2 rungs that really have to do with data. So at that point, now we're talking about, well, what are we going to do with it? What kind of model do we want to build? What kind of AI do we want to do? And I think about that in the areas that are kind of surrounding the data here. There's the specific task that you're looking at, and that's really what goes on the analyzed rung of the ladder. What exactly are we going to predict or estimate or whatever? And then the use. How is that going to fit to your general workflow? It's really refused rung of the ladder. About the task, I'm really talking about fine-grained. So, for example, predicting.
Kristen,
talking about.
Kristen, hold on just a second. I don't know if it's just me or maybe it's everybody, but the audio's coming in real choppy. Hold on. Kristen? Oh God, this is terrible.
Very precise.
Hold on just a second.
Predictor estimator.
Wow. Okay, well, we have lost Kristen, and Kristen was pretty much the host of the show. She was also running the PowerPoint. I could probably get it pulled up here in just a second and have that ready for everybody. No worries at all. We've had a whole bunch of questions come in, so let me see if I can get this booted up over here. I should have had it already ready to go. Got a couple of comments coming in. Everybody saying losing audio, lost audio, losing audio, losing audio. Yes, no worries. It's okay. Maybe Kristen was definitely in the groove there, and I hope that she will see that it's it's kind of like one of those times where you're talking on the phone and then the other person loses connection, but you don't realize that they lose connection and you just keep on talking, and then like 30 minutes later you're like, hey, what did you last hear? Sorry, we're just kind of I also booted a couple other people from the show just to see if that would help. Sorry, Gandhi, about that one. I see that you're jumping back on. All right, so give me just a second, you guys, and hopefully we'll get this show turned around and we don't lose everybody that's watching. So let me see here. Well, I think she was the last one. Let me bring in Jeff here real quick. Jeff, what are you thinking? What should we do, boss?
I think we should give Kristen 1 more minute to see if we can get her back on.
She just popped in here.
There we go.
Device is not connected, though. It's okay, guys. Hey, this is the Vidor Luxman show, and this is the kinds of things that happens, guys. So guess what? No big surprise. All right, Jeff, I'm going to boot you off there. Kristen, we lost you.
I'm so sorry. Where did you lose me?
I don't know. I think you said something about artificial intelligence or machine learning.
Are you serious?
No, I'm just. I mean, you probably said it somewhere there. I'm not sure of the exact point that things went south. But if you would go ahead and bring up the presentation.
Yeah.
And we'll get that shared. Oh, that's right, because I can't do it because I'm on Chrome, and Chrome doesn't allow me to be able to do it. If I do it, then I get booted off, and then nobody's in control.
All right.
So if anybody that's watching can say, hey, this is exactly where we lost it, feel free to add that back in. All right. So I think, yes, you were on the next one. Yes,
this one?
We were on this one where we lost. Okay. And action.
Thank you. Less terrible than I thought. I apologize for the disruption. So yes, to reiterate here, once we've done all of that with the data, we're kind of halfway up the AI ladder. And now we look at what we're going to do with all that data with our AI or machine learning. And so surrounding the data here, you see that I tend to think of that in terms of the task and the use, right? So the task corresponds to the analyze rung of the ladder. It's the specific machine learning or other kind of AI task that you're going to do. And the use then is about fitting it into your workflow, and that's the infuse rung of the ladder. So when I talk about the task, I'm really talking here about the very specific and precise task that you're doing. So for example, Vaisakhi talked about estimating or predicting the fracture dimensions of length, width, and height, right? Those are very individual, precise values. I'm talking about it at that level. Now, that individual thing that you're going to build a model for may only be part of a full solution, right? So you predict those fracture dimensions in order to feed that into some optimization. So that's part of the fuller solution. But you want to be able to define that exact thing you're looking for. So something numeric, like in Vaisakhi's example, or in some of the text examples that Gandhi talked about, it's things like, what exactly do you want to find in the text, like representations of certain kinds of incidents, right? So you need to be able to get down to something that specific. At the same time, it's important to note that they need to be things that require some element of judgment or estimation or prediction, because that's why you're using AI, right? So to go back to Vaisakhi's example, she was predicting those fracture dimensions from the stress profile using machine learning because there's not a direct mathematical relationship. If there were a direct relationship, you would just use it. You wouldn't be bringing AI into the picture at all, right? But when there isn't, when you have that combination, really AI and machine learning and these kinds of techniques shine, when there's something very specific that you're looking for, some individual concrete thing, and there's some element of judgment or approximation in the task. That's when you're in good shape, as long as the data supports it. So I said we were past the data part, but I'm going to take a brief detour back into data for a moment. For most of the things that we're going to do with AI, you need ground truth, because most modern AI, not all, but most of it uses supervised machine learning, which probably this is totally old hat to some of you and not to others. So just to take a brief detour, that means that the AI is learning from a bunch of examples where you've given it the right answer. So you've given it this wide variety of examples where it's seen the right answer. It learns with one of many, many different techniques, patterns, so that then when it sees something new that's not an example it's seen before, it can predict what the right answer would be in that case. So it's very important for that to have a wide variety of representative examples where you have the right answer, and that's the ground truth. So when you're thinking about the task, you also want to think about where that's going to come from. In some cases, it's naturally occurring. It's a value you're collecting. You just want to predict it earlier. In other cases, somebody's going to have to go indicate what it is. You're going to have to create it. So you need to know, is that going to be very demanding? Is it not? Does it require deep subject matter expertise? So you want to think about that too. But once you have the kind of task that we're talking about and you have that ground truth, then you're in great shape for your data scientists to use any of the kinds of techniques we just heard about and many more to give you results that you can then infuse into your workflow, right? So then we talk about infusing, and we look at how do we really operationalize AI throughout the business. And I tend to look at this, you have your model at the center, whatever you built up. And then I look at this in terms of sort of two different tiers or levels working outward from that. The first is the technical environment and the use of the output of that model directly. So how is it going to fit into your workflow? What are you going to do with it? What are people going to do with it when they see that outcome? And when you plan that, that has to take into account that there is going to be some uncertainty, right? This is AI, it's predicting things, it's not something where you measured an exact value. So if you think about the example that Gandhi talked about at the beginning with predictive maintenance, right? You want to think very carefully about exactly what are you going to do? Are you maybe going to overreact a little bit to some of the predictions because the predictions are approximate and you want to account for the fact that if they're approximate in the direction of underestimating what's happening, you want to have reacted to it? Are you going to have some other things? Are you going to combine them with other insights? You want to think that one through. It's also part of defining your task at the beginning. How precisely accurate and certain does it have to be useful to you? Do you want to block some of the things where the system is less sure and only show the ones that it's very sure about? You want to think through things like that. Also, what systems do you need to integrate with, and how's that going to work? And that can range from just, showing a value in an interface that says, here, machine learning suggests, an estimate of this particular value, through being part of a much broader chain of reasoning, such as predicting values that then go into an optimization, the way Vaisakhi talked about. And then there's the broader infusion into your business environment, the kind of softer side, right? First question there is, are there policy constraints? Quite often there are policies that are going to mean that there are specific characteristics your AI has to have. And you want to think through how you're going to do that, how you're going to accommodate that. It may mean that you need to use certain kinds of techniques, or that you have to have done certain kinds of testing, or you have to have certain kinds of explainability, right? And then you want to look at, okay, the people who are going to use this updated workflow, how do they feel about AI? What's their enthusiasm for it? Do they have history with it? Are they, excited to try it out? Are they highly skeptical? Do they expect it to be magic? I often find there's just as much difficulty when people expect it to be total magic as when they're very skeptical and don't think it can help them. But in any of those situations, you want to really set their expectations and do some change management, right? And tell them what it is going to do for them, and perhaps introduce it gradually. And how much you do that and how you do that does depend on the kind of use. So to refer once again to Gandhi's presentation, think about something like the well completion reports, right? That's pretty easy to introduce. It's very natural, right? That what the system is doing there is, in some sense, drawing human beings' attention to the right part of text documents where there's way too much for them to read themselves, but it's pulling out and saying, here's something that you should know. They're still reading it themselves. They can still decide it for themselves. They can still see the whole document if they need to. And so that's pretty natural for people to accommodate in their workflow and start using. It probably doesn't need as much change management as something like predictive maintenance, where people are going to wonder, well, what does it mean? Should I believe how certain it is? How am I going to use this? How do I know that what it's doing is really correct? And so there, you're going to want to introduce things probably much more gradually. And also, ideally, you might have some tools that help you do things like provide some explainability of what's inside the model, watch for when the incoming data starts to be different from what you trained on, and adjust your confidence or retrain as a result of that, and do things like that so that it's very natural to use. But either way, you're going to want to do some introduction and change management of that kind of thing. And once you're all the way there, then you've climbed all the way up the ladder. And, that's where you get to with something like some of these success stories that we were just hearing about. And so open for questions. And thank you.
Excellent. Thank you so much, Kristen. Now, we do have a bunch of questions. So the most recent one right here is, do you find the adoption of AI in a company is driven by management, the technical people, the IT people, or a combination of all three?
So I would say a combination of all three. And I would say, if any of the people you just listed are not enthusiastic, there's something to address there, right? That's going to be an issue. You sort of need all on board. What I do find, and this is also echoing something Gandhi touched on, is that it tends to be most effective to start with something small and show success. And then you want to consolidate and have that kind of broad enterprise support that Jeff talked about, right? You want to kind of be able to point to something and say, here, we did a thing and it worked out well. And look, it shows some value for line of business. You can see it. Then at that point, if you let everybody run off and do their own thing, it starts to get disjointed. People may get stuck. We do really want to watch for getting stuck in kind of proof of concept limbo, where everybody says, oh yeah, I can do that. And everybody does their own proof of concept and it's not clear what's going into operation. So you do want some support from the top to make sure that there's some strategy on how you expand that. And often you'll find yourself going to sort of a hub and spoke model, where there's some centralized work on AI in the organization, and then there's some deployment and specificity within line of business that builds out on that.
So to get a little bit more granular and technical in this, like, how big of a data set do we need? To be able to just say, like, because the thing is, for me, is I would love to be able to, for this to be, democratizing, artificial intelligence, machine learning, and being able to get it out there to even the smallest of companies. Like, what do they need at the smallest level, how big does this data set need to be? Like if there's 25 different scenarios, do they need, is it 25? Is it 20? Is it 30? What's some of the basic level numbers there for somebody to be able to say, hey, we've at least done our first part in capturing some data to be able to approach an AI company?
Yeah, absolutely. So I'm going to give the annoying technical answer of it depends, but then I'm going to expand on that.
Fair.
Depends on a lot of things. So when you're doing supervised machine learning, you typically need a lot of examples. Depending on the technique you use, what a lot means can vary, right? We're usually talking in at least the hundreds of examples. Now remember, an example is an instance of something. It's not your description of the scenario, right? So if you've, I don't know, measured the weather for hundreds of days or something like that, and you have the characteristics of those days, if that's your goal. When you're talking about some of the sort of deep and sophisticated things, you may be talking about thousands of examples. Having said that, there are a lot of techniques to use something that's trained and then tune it a little bit for an individual use case. So if you're lucky, your machine learning problem may be one where there are already some trained models that you can take advantage of, and then you don't need nearly as much data, right? So there's been a lot of advances in language processing on that basis lately, where you've got a few big institutions going out and combing tons of data from various public sources and building this sort of general language model that then you can tune for your own individual situation. Other thing I should mention is that not all AI is machine learning, right? So there are situations where what you want to do is really represent your knowledge and your knowledge base and build up, whether it's a comprehensive set of rules or provide a bunch of knowledge that can be used by something that's either machine learning or some other algorithm. And so if you're providing reference data of that type, then it's not so much about the quantity as it is about the comprehensiveness for the scenarios you want to cover. So I hope that was a little bit better than just it depends.
I'm just trying to get an idea of like how small a company can actually be to be able to implement something. So maybe Kristen reports. We're a small company. It's just me, right? It's me, the camera, and the light up here.
Right. So the other thing that I should mention is that for some AI tasks, there are fully packaged models that you may not need to adjust at all, right? So if you want to recognize standard kinds of entities in your text, or if you want to recognize certain common images in pictures, you may be able to just use that. You don't have to train it necessarily. You need to train it yourself. Well, there are a bunch of online tools, both IBM has them and open source, where you can kind of try it out with some examples that you have and see how you do with whatever data you have. But typically, hundreds of examples of whatever you're looking at is common.
Okay, excellent. So this one says, if you are at, say, stage 3 of the AI staircase and realize you need to include another data parameter at stage 1, how easy is it to do that? Example, you think you don't need bit hydraulics to predict ROP, but later on you find out that you actually do need the hydraulics information.
Yeah, so that's a great question, and it really gets at the weakness of the latter metaphor that we like to use, right? So we like to use it because you have to think about things in that order to get started. But absolutely, if you find that you need the hydraulics information, question is, you have to go back and say, well, where am I going to get that, right? If you already have it and you just didn't think about it a lot, it's pretty easy to add it back in as you're doing your analysis. If you didn't collect it, the issue is, well, then you got to go collect it, right? You have to go find it. And if you didn't collect it when it was available to you, are you going to have it for all of those examples that we just talked about creating in order to train your machine learning? So that's where it becomes tricky, which is why usually if you ask a data scientist or a machine learning person, like, how much data should I collect? They'll give the answer that's almost as annoying as it depends, which is everything, right? Because you never know what you're going to need. Yeah. So usually that's our advice. Data storage is pretty cheap. Try to get as much as you can, and then you can have your choices to make as you create your model. But it's not really a problem to go back and add another column to the database you're using. It's only an issue if you didn't collect it, if there's no place to populate that column from. Does that make sense?
Yes. So we got another question here. Metadata or semantics is missing in most of our drilling data. How to process when we don't have the semantics or the metadata?
Yeah. So
There's an
best
answer
case-
you want to say, but you didn't say it there.
That's right. So best case, get some semantics. Barring that, there are machine learning techniques that may work for you, right? The machine learning doesn't really care what the individual semantics are. We care as we set up what the features are the machine learning is looking at. They need to be ones that are relevant. And we care because if you're pulling from different places and you have a single feature, you want to be pulling things that have the same meaning into that feature. But having said that, you can look at techniques that are used on, say, raw images. Each pixel doesn't have a whole lot of semantics, right? And it's just about, hey, what are the patterns in here that we can find? Typically, the less you have in the way of semantics you understand, and therefore the less you can kind of engineer your features to know they're meaningful, the more you're going to have, the more data you're going to have, and the more complex and sophisticated methods you're going to need to use.
Here we go. So Eric asked, can AI provide a simplified explanation of the reasons for choosing an option or another?
Yeah, so this is a topic that I love to talk about because we used to have a terrible answer for that in AI, and we're definitely getting better. So a lot of the most effective machine learning methods are kind of black box-like. It's hard to look inside them and understand what's happening in a way that a person can kind of follow along with. But there are now methods of saying, sure, that's fine, but we can have another process that's running alongside that AI that kind of monitors it and can tell you, here are the features it's relying on most heavily. Here's what it looks like led to this decision, right? If you're saying one option rather than another. If I change these couple of values that look like they were contributing a lot, the AI would have given you a different answer. So guess what? Those are the things that really made a difference. So we're getting to the point now where we can start to provide those kinds of human consumable explanations.
I love this question, by the way, John DeWart. Awesome question. Can you share any AI horror story and lessons learned? I'm all about learning from failures. So what can you tell us?
I have an AI horror story. I'm going to try to genericize it to protect the innocent and the guilty. And I will say from the beginning, it's not an oil and gas horror story. So maybe somebody else has that one kind. But we did have a project where the client was asking for AI in order to recognize, how am I going to say this, that certain kinds of things were happening in their documents, right? So they had a big unstructured document collection, and they wanted to be able to provide, if somebody says, can you find me examples of X, bring back examples of X. So think about, say, Gandhi's example of finding descriptions of certain kind of incidents in documents. It would be analogous to that, right? And so we said, great, we're going to put together a type system of the particular phenomena in the text that the system's going to recognize. And then when it recognizes certain phenomena in certain relations to each other, that should represent what you're looking for, right? And they said, great, or we thought they said, great. But in their minds, an AI was like a hive mind, right? And we kept trying to get tried to get their subject matter experts, and we apparently were not very good at expressing what we needed, to mark up examples of the phenomena to recognize in an individual document. Here's where somebody's saying that an incident happened. Here's where they're saying the severity of the incident. And in the client's minds, what they needed to do was explain the meaning of an incident and the meaning of severity. And we just had a total disconnect. And they were very frustrated. And it was kind of a horror story. And I don't have a great outcome ending for you. I mean, in the end, we did something that was okay. But, it just never gelled because we weren't really able to communicate about the content of the task that we could train something to do. And that horror story is one of the reasons that goes into why I stamp my foot about identifying this very specific, concrete point task that you're going to have. You're going to have a model to do, even if that's part of some broader thing that to the end user feels very magical. Each individual piece is like not magical. So I don't know. That's my AI horror story.
I do have give you guys the chance to do a plug here. How and where do listeners go to IBM's AI site to try out some of the data analytics and AI solutions like AI visual recognition, speech, text, sentiment analysis, and AI debater?
Yeah, so you can go to IBM's site, and I think at watson.ibm.com, and probably you can get to it in a few other ways. You can get to our AI branded and Watson branded offerings, and there are light versions you can try out for free. So give it a try, right? And see what you think. To do heavy processing, of course, it's not free, but to try it out and get a feel for whether you want it, it is. I will point out, Ben put a long list in there. Some of those things are IBM research projects where there's not like a light version of a product to try out. So you might need to call us if you want to work with that. There are some outcomes of research projects like Debater that are getting pulled into our products, but you won't see it labeled, here's Debater.
All right. So one of these. So in other words, specifying the end requirements is clearly important.
Yes. Yes. And
in other news, water is wet.
Yes. So the thing I would add to water is wet and you need to put it in containers or something, right? So, right. You need to specify the requirements and you need to get to a level of granularity for the individual technical things you're doing that you can execute on them. So requirements like help me optimize my process are a great starting point for the business, but don't have the granularity you need.
Which is actually kind of funny because Drew would put on here, Scott Manigault, that is the core of software engineering. I actually sent him a meme the other day because we do some data software projects. It was like AI is going to take over software engineering. And then it was like, this means clients are going to have to tell AI exactly what they want. And then it was like, yeah, I feel comfortable with my job. So
I think you can.
Anybody's ever done with the software engineering, yeah, they know exactly what the problem there is. So let me bring back in Jeff. Jeff, thank you guys. Thank you, the entire team, so much for being here. Did we miss anybody or did we get through everybody?
No, we got through everybody, David. Thank you.
All right. Okay. Guys, if y'all have any more questions, be sure to fire them off. We'll kind of get things rolling right along here again. I really do appreciate you guys all watching. And I have to put this one out there. David Reese says, I love that show too. I'm not sure what he's talking about, but I'm guessing the other show that he's talking about is this one. And if you guys haven't, be sure to reach out or see some of the stuff that David Reese putting on. So there's called the Red M Project. It's about human trafficking and sex trafficking. It's a project that he is spearheading and moving forward. If you guys can, please get involved. It's a very important cause. We've got excellent. Ryan Dugas says, excellent. Thanks. Another LinkedIn user. This was probably either John DeWart or Scott McNeil. I can't remember which one because it keeps doing this thing. Says David and IBM folks, excellent presentation. Very well delivered. So, and then we also got Elio Gomez says, great presentation. Guys, thank you all so much for watching. Really appreciate. Oh, here we go. Another one says, really appreciated IBM putting this show together. Thanks. All right. Kristen, Jeff, thank you guys so much for being on the show. I do appreciate it. There, now that we're at the Q&A section, it's actually the end. So I'm going to go ahead. We'll let you guys go ahead and go. Thank y'all for being here. We do appreciate it. And then I've got some just a couple of words coming out on the other end. So we'll take that. Thank you, Kristen. All right, guys. So quick update and news from me. This is the last show for a couple of weeks. So I'm just going to take a little bit of a break. Viewership has been dropping off a little bit. We haven't been getting quite the engagement as we were before. A little bit of that's to do with LinkedIn. I can't send out all the invites that I want to. And I want to make sure that we're getting the right guests to be able to come on the show. So I'm going to concentrate back on Gibson Reports because this show is actually brought to you by Gibson Reports, gibsonreports.com. If you need to know anything about directional drilling business, MWD business, let me know. I probably will be going live maybe sometime next week. I think I'm going to do just like a special one-off, not really specifically a VDOR locksmith show. Other than that, I will put this one back up there. Be sure to check out next week, the Crude Audacity podcast. I would appreciate you guys, if y'all have the time, tune in, watch, listen, whatever. Give it a chance. I will say this. I noticed something that happened yesterday. If you are paying for followers, your content, like paid like click farms for followers, like not real people, your content's not going to get spread as far as you think it is. And it's going to be really hard to be able to compete with this show. Just saying. Putting that one out there. We had a whole bunch of people in here saying, thanks, David. Build some more Legos. I'm glad you said something, Drew, because check that out. I think if I Yeah, it's just like the logo right up there. I built that, you guys. Check that out. Wait, where's the... There it is. It's even got little things here. Fun stuff. Guys, as always, I'm taking a quick break on the show, so I have no plans as of coming when we're going to come back. Everybody's texting me right now. I have no plans on when the show will be coming back. It will come back at some point in time, but we just need to take a break. So I have to say this from the bottom of my heart. Thank you guys so much for watching the show. Thank you so much for being a part of this and the engagement and likes, the comments, and everything else. But we're going to take a break for a little bit. We're going to kind of rehash and probably come back and do things a little bit different. Get more engaging stuff to where we can talk to the audience even more. So if there's anything you guys would like to see, if there's anybody you would like to see interviewed or have on the show, let me know. I appreciate all of the support. And as always, guys, know your industry. And I didn't have the button lined up. Once again, I screwed it up there.